MacMaths, MacMaths, let's do some math today. Statistics. Okay, this is more about sort of percentile problems. It's more really, I'm just going to go through some of the questions with you on exercise 2D. So let's just sort of get started. I found a few little issues with these actually. I'll just put that one there. I think you can sort of see that. I'll do the question at the side here. And the little issues with them are to do with the rounding. It's you've got to estimate things. So how I would round them, how the back of the book, the answers around them might be sort of slightly different. But I'll go through the maths with you anyway. Okay. Let's go through. There's 2 or 3 I'm just going to look at, that's all. So I keep saying it'd be a short video, but then when I film them and look at it, it's like 30-40 minutes long. So that's statistics for you though, isn't it? Okay, so here we go. The first one was about this question in 2D. Question 1 was about slow worms. Slow worms are, if you don't know, a type of sort of snake common to indigenous to Great Britain. It's one of our few snakes. And sounds like a worm, but it is actually a snake. And they got the length of them in millimeters, so you can see they're quite small, really, 20 up to about sort of 23 centimeters. So the biggest one in this survey is about that. There's 10 of them, and some little ones, just 12. Look at that little. They look like worms, wouldn't they? So we've got to work at. First question says, how many slow worms are there? Well, just add up the frequency. Let's just do that. So 4 add 4, add 2, 8, 10, 10, 20, 30, 40, 50, 57, 61, 71. So there are 71 slow worms. Estimate the interquartile range. So we've got to estimate the interquartile range. So this is the first bit of maths, isn't it? It is, because it's length, it is continuous data. The groups here, what we're going to do is we're going to go half above and half below, aren't we? Because they've been rounded off to the nearest millimetre. Okay, so that's how we treat it when it looks like discrete data, but actually it's not discrete data, it's continuous data. So let's do that. So because it's continuous data, then we use so this is for B, we use the n over 4, so 71 divided by 4 is going to be 17.75. So that's this is Q1, okay, so we want the first quartile, so Q1 is 17.75 term, so that 4, 8, 10, 17, oh blimey, so 4, 8, 10, the first 17 are in there, so we want 0.75 into this group here. So we've got the group which is 185 to 199, so we're going to do we're going to really look at the group from 184.5 to 199.5. Okay, so that's in real terms, that's what the group is. And we've got how many people in that group, or how many worms have we got in that group? We've got 20, so there's 20 of them between those two limits. And oops, I normally put the 20 at the bottom, don't I? What's the gap? 199.5 minus 184.5. You would think I'd be able to do that in my head. I can't. So the gap is 15, and we're going to go 15 divided by 20, okay, because that 15, we're going to divide it into 20 equal bits. So each worm in that group is 15/20ths along, and that would take up the whole 20. And we want to go 0.75, so 0.75 in that. Okay, so 15 divided by 20, which is 3/4, times 0.75 is equal to that, 0.56. So, but we've got to, that's how far it is into that group, 0.5625. And we've got to add it onto that, so plus 184.5, and it gives us 185. So Q1 is 185.0625. If we do the same, 3n over 4, so times that by 3, 17.75 times 3. So 3/4 of 71 is, we want the 53.25th term. Okay, so now we're 10, 17, 27, 37, up to 37. I'm just doing the cumulative frequency on this. 4, 8, 10, 17, 27, 37. Yeah, so 37, so it's in this group here. Okay, so 53.25. If we take off the 37 that comes into the groups before, it gives us, so minus the 37 from the previous groups, it's the 16.25th term into this group here, and that group there is 199.5, being careful of the limits, isn't it, to 214.5, and we want the 16.25th term in that. Okay, so first of all, the bandwidth for that is the same, it's 15. Okay, and how many are in that group? 24. There's more worms in that group, so we've got to split that into 24 equal pieces, and we want 16.25, so we're doing 15 divided by 24, that's each increment in the group, and we want 16 of them. 16.25 times 16.25 is equal to that, and then when we get that, we've got to, that's how much it is into the group, which would be 10.1, so we add it to that, so just go straight to my calculator, plus the 199.5 is equal to that. So what we've done, we've gone 15 divided by 24, times it by 16.25, and then we've added the start of the group on 9.5, and that has given us 209.625. Okay, so the interquartile range is that, take away that, isn't it? So is the gap between 209 and 185. Okay, oops, just drop my pencil. Minus 185.0625, and that gives us 24.6 rounded off. So the interquartile range is 24.6 millimeters. Okay, so there we go, and that was that one. Take away that one, Q3, take away Q1. Estimate for the mean. I'm not going to do this one, I just looked up the answer in the back. That's just your midpoint times frequency. Midpoint, when you do the midpoint, you don't need to do between the two ends because it's half above and half below. It would still be the gap between those two. So add those two together, divide by 2, and that's your midpoint. Okay, so midpoint times frequency, and that, if you did that, gives you a mean. Okay, and for the mean, remember, it's x with a dash over the top. Okay, and it works out at 24.6, and you'd expect that, wouldn't you? That looks sensible to me. 24.6, oh, does it? It says calculate an estimate for the mean length. That does not look sensible, does it? 24.6. Oh no, hang on a minute. That's the interquartile range, blimey, sorry. The must be 193, sorry. Right, I'll have to look that up in the back, sorry, I made a mistake there. Looking it up, let's have a look at what the mean is. So 2D, I'm not working all that out. 2D question 1C. Question 1C is 193.1. That looks more sensible. 193.1 millimeters. Okay, so if you do, that's why it's sort of checking, isn't it, whether it's sensible or not. So the estimated mean, midpoint times frequency, you do that, you get 193.1, and that does look sensible. Okay, now then, the last bit. Okay, if we look at the last bit then, just rub that out now. A little bit of controversy here with the last bit. Me actually giving you the wrong answer there. It says estimate how many slow worms of length is one interquartile range above the mean. Well, the mean is 193.1, and the interquartile range was 24.6. So we've got to add those two together. So that's the mean plus one interquartile range. So plus 193.1. So that is 217.7. So how many slow worms are bigger than 217.7 millimeters? Well, that's in this last group. Okay, so if you look at this last group now, okay, this last group goes from snakes that are 214.5 to 229.5. Okay, and we want the and it's actually, there's 10 snakes in there, so 1 2 3 4 5 6 7 8 9 10. There's 10 snakes in there. Okay, and we want to know, if this is 217.7, how many snakes are out of those 10 are bigger than that? Okay, so we just need to find the position of this, in the group. Okay, so all we do, of course, is go 217, take away the 214.5, that leaves us 3.19 into this group. Okay, that's where it is. It's 3.19 into this group, or 3.2. And what is it? It's 3.2, not snakes, but it's 3.2 out of, millimeters out of the 15. So it's 3.2, and there's a gap of there's 15, so it's 3.2 fifteenths, isn't it? That's what fraction the snake of that length is. Okay, so that's what fraction it is within that group. Okay, and we want to know if we times that by 10, so what fraction of the sort of 10 snakes is that? And when you do that, okay, so 3.2 divided by 15, okay, it's 0.21 in, and obviously if you times that by 10, you get 2.1 snakes in, or slow worms. Okay, so effectively the 217, that point there, is 2.1 snakes into this group of 10 snakes. That's where it is. Now the back has given an answer estimated at the 7. So what they've done is they've rounded off. They've gone 2.1. So as an estimate, they've taken the first 3 snakes in that group, okay, and then gone 7. I don't know why they've done that, whether I would have sort of rounded down to 2 and said there's, as an estimate, there's 8 snakes, but they've rounded up for some reason. But I don't think you'd lose a mark for that, as long as you get that math, you understand the maths. Okay, so we found that position, we found how much it is in, so what fraction is that into that group, and then it's the same fraction of the 10 snakes is what we've taken. Okay, so they've said 3, rounded up to 3 snakes, so 7 snakes are are bigger than 217.7. Okay, that's that one. I won't do 2 and 3 are virtually the same, so I'll just do question 2 for you. Question 2 is very straightforward. It's nice because the groups are using the continuous, the crocodile mouths for this one. So 3, 24, 28 and 15, I suppose we better add that up first. So 3 add 24, add 28, add 15 is equal to 70. So the table consists of 70. So this is the table that shows the monthly income of workers in a factory. So 3 of the workers earn between £900 and £1,000. I wish the school paid me that much. Not really worth it, am I? 3 of the workers earn between £9 and £1,000 a month, and so on. So that's what the table. And it's saying part A is calculate the 34% and 66% percentile. Okay, so 34 out of 66 makes 100. So what they've done is, the 0 to 100%, what they're doing is they're going in 34% from each end, aren't they? And they're going to ask you estimate the number of data values that fall within this range. Okay. All right. So that's what we're doing now. So the 34 percentile. Okay. So we just go 0.34. That's how you find out 30% of 70. And remember what I said. Now we don't call it Q1. We call it P34 for the 34th percentile. So 0.34 times 70 is equal to 23.8. That's a 23.8th person. Okay. 23.8th person. The interpercentile range, the 23.8th person. So 3 in there, 20. It's going to be in this, isn't it? So just take 3 off. So 3 are in this group, so it's going to be in this group here. There's 3 already in that, so we take 3 off there. So 20, we want the 20.8th person in the group that goes from 1,000 to 1,100. Okay. That has a gap of 100, and it has how many people in it? It has 24 people in it. Okay, so we're going to do 1,000. We're going to do 100 divided by 24. Okay, so we're going to split that group of 100 into 24 equal pieces, and we want 20.8 position. And 20.8th position, and then we're going to add it on to 1,000. Okay, and that's our P34 percentile. So let's do that. So 100 divided by 24, and we want 20.8 bits of that. Okay, and we're going to add that on to 1,000, and that gives us 1086.7 rounded off. Okay, and that is pounds. So the 34 percentile means the 23.8th person earns £1,086.70 as an estimate. The P, what's the other one? 66. So we're just going to do exactly the same maths. Times 70. So 0.66 times 70 is equal to, I'm always nervous doing this because it's not my thing. can do the questions, but I can't do them, you know, I've got to think about each one because it's not fluent to me, it's not natural. So we want the 46.2th person. Okay, well, that's going to be in this group here. We've got 27 of them first of all, so take off 27 is the 19, so minus 27, so we've got the 19.2th person in the group, which is this one here, from 1,100 to 1,200, the gap's 100, and there's 28 people in that group, so we're going to do 100 divided by 28 times 19.2, and then we're going to add that on to 1,100. So 100 divided by 28 people in that group. We want 19.2 of those positions into that, and then we're going to add that on to the start of the group, which is 1,100, and that gives us 1168.57. Okay. And that's it. Okay, it is asking for the percentile range, so the percentile range is that, take away that, so minus 108.6.7, so the percentile range .87. Okay, so that's the answer, the percentile range. That means that between 34 and 66, what's the gap between 34 and 66? 32. The middle 32% of workers have a monthly difference of £81.87 is effectively what this estimate is. Part B, there is a part B to that. It says estimate the number of data values that fall within this range. Number of data values is the number of people, and the number of people, well, between 34 and it's not a lot of maths here, but between 34 and 66%, there it is. Okay, there is a gap of 32%, isn't there? So it's 32% of 70 people fall within this data range. So that's all you're doing. You just go in 0.32 times 70 people. Okay, and it's how you want to round that, 22.4, you know, as an estimate, 22 people. Okay, fall within that range. So all we've done is found 32% of 70, and 22 or 23 would be an estimate for that. Okay, it is only an estimate. Okay. All right, so that's okay. Yeah, just check the back of the book there. They've given it as 22 people. I've done. So, question 3 is exactly the same as question 2. It's just giving you the 5% and the 95% percentile, so just doing the same thing. But I thought I'd just do this last one. The last one, basically the last one just gives you some numbers here, some temperatures in Leeming in June 1987, and you've got to calculate the median and the interquartile range. So it's discrete because it's just giving you actual values, so you're treating them as discrete. So you just go in n+1 divided by 2 and doing that, put them in order and so on. Okay, and it's asking you to compare. Whenever you compare things, you know, you just make a comment about the range and the spread. So the mean or the average and the spread, and you just say what you see really. Which one has the biggest average and which one has the biggest spread. That's it. That's all you do. However, on this one at the end, it says something not based on the numbers in the question, but it says the P10 to P90 percentile range for July was 5.4 degrees C. Okay, so in July, between those is 80% of the days. 80% of the days were within 5.4 degrees of each other. Okay, this is the daily average temperature. Estimate the number of days that temperature fell within this range. Okay, well, for that one, you just got to know how many, because I thought about this one, I thought, oh, it's not really connected to the numbers in the question, it's just a maths question. And so for part C, if you're thinking about this one, you just got to think how many days in July, January, February, March, April, May, June, July. There's 31 days in July. The range between P10 and P90 is 80%. That's the gap. So 80% of the days fall within this range. Okay, this 5.4 degrees Fahrenheit. So you've got to do 80%. So of 31 days. So 0.8 times 31. And when you do that, 0.8 times 31, you get 24.8. Okay. So the temptation there is to go, oh, it's closest to 25 days. But actually, if this is days, just think about this one. I don't think you're not going to lose more than, say, a mark if you've made the wrong call on this one. But the range is between, it's talking about a range between 5.4, change between 5.4 degrees. And if 24.8 days, 24 days, it's within that range. 0.8 of a day, it's within that range. So in one of those days, 0.2 of the time, it's outside of that range. So actually, the answer here is only 24 days, full days, it's within that 5.4 degrees C range between the 10th and the 90th percentile days. Okay, so you just go with 24 days. Would you lose, if you showed the working, would you lose any marks if you went 25 days? Not sure you would. Okay, it's only a 1 mark question. Alright, and that's exercise 2D. There's no more questions on that. Alright, so have a go at those. Hope that made a difference. Okay, hope you're okay with it. And go away now and Google slow worms. Okay, so you can see what one looks like.